Welcome back to part 3 of computing with multi-digit numbers. We're going to finish up this lesson today with this part, and you can see we're starting off with a pretty ugly problem. We're dividing 60,927 by 12 thousandths. First question is, how do you set up the division? Well, what number goes in the house? Always the first number. So the 60.929, that goes in the house. They also ask, what do you need to multiply both sides by to eliminate the decimal point in the divisor? The answer is going to be 1,000 because you have 1, 2, 3 decimal places, and to get the decimal to move 3 places to the right, you have to multiply by 1,000. Now, we don't really show that. We just go whoop and bounce the decimal 3 spaces, but that's essentially what you're doing, is you're multiplying both numbers by 1,000 to move it 3 places to the right. So let's get started. We've rewritten the problem with the first number in the house, just like I said. This decimal right here, it's outside the house. It's 3 spaces to the left of the wall, so we're going to bounce it 3 spaces to the right. The decimal inside the house, we're going to bounce 3 spaces to the right as well, so that they both inside and outside move the same number of places to the right. So now you've got 12 divided into 60,927. The decimal went away, but it didn't really. It's right there after the 7. That's where it ended up. And you know that when the decimal's on the end of a whole number, you can just make it go away. It doesn't have to be there anymore. Now comes the fun part, the long division. Now, the textbook chose not to make you suffer through the entire division process because it's brutal. I mean, it's a lot of work. Instead, they just went boom, and there it is. Now, you can see that when they got to this point right here, they had not terminated their number yet, so they had to keep going. So that invisible decimal, they brought it back in. And what did they do with it? They moved it straight up. They annexed in zeros as needed, just like we'd shown before, and kept dividing until they got to that point right there where they did not have a remainder anymore. You might ask, how far do I have to go? Mr. Reed's general policy is going to be that you go 4 places after the decimal. If you've made it to 4 places after the decimal and you've not gotten to the end, odds are pretty solid that you made a mistake someplace, somewhere. You can stop at that point, grab a calculator, and check your work. If your work says keep going, if the calculator says you're close, keep going, then keep going. But I'm thinking that if you make it 4 decimal spaces and it doesn't end, you've probably screwed up. In the end, the answer that you'd put there is the same answer that you see up there. We're not going to bother plugging it in because we know what the answer is. They gave it to us. Now, the problem did ask, why is the quotient, that's the answer to a division problem, so much greater than the dividend? The dividend is the number that's being divided. And the reason for that, if we went back to the original problem and looked at it, is because, actually look right here, it's because the divisor, the number we're dividing by, is teeny tiny. And when you have a number less than 1 that you're dividing into the number, your answer is going to be bigger than the number that you actually started with. Now it's going to be your turn. I want you to pause the video and solve this problem while I finish up my dinner, the boy food that I think we talked about in part 2. Go ahead and do that now. Did you get it done? Let's see how it works for me. Now, I'm going to start off by bouncing. First, I put my first number in the house, just like I've taught you. I'm going to take the decimal outside the house and bounce it 1, 2 spaces until it hits a wall. I'm going to take the decimal inside the house and bounce it 1, 2 spaces to the right, and I'm going to move it straight up. Next, I'm going to take my 36. 36 goes into 8. How many times? 0. 36 goes into 84. Yeah, but how many? Well, let's take and break this down. I'm going to say 36 is close to 40, and 40 goes into 82 times. So let's do 2. 2 times 6 is going to be 12. 2 times 3 is going to be 6, plus the 1 from the 12 is going to be 7. And when you subtract that out, we get 12 left over. This 2, bring that baby down. And now we're going to have to divide again. Now I'm going to say, well, once again, how many times is 36 going to go into 122? Well, that's pretty hard. So in my mind, I'm going to take and round this one up here up to 40. I'm just going to pretend it's 40, and I'm going to scratch out the last digit on each one. And I'm going to say how many times does 4 go into 12? 4 goes into 12 3 times. So 3 is going to be my starting point that I'm going to test with. I'm going to put in 3. 3 times 6 is going to be 18. 3 times 3 is going to be 9, plus 1 from the 18 makes it 10. And when you subtract that one out, we're going to do some borrowing. That becomes a 4 and a 1. We have 14 left over. And now that 4 comes down, giving me 144. Alright, it is time for us to finish this problem up, I think. So now we're going to say how many times does 36 go into 144. And we're going to take and try 4. I actually tried 3 before and I got the wrong answer, so I'm just going to skip that, and we're going to try 4. And when we do 4 times 36, we get 144 with nothing left over. So our final answer is going to be 23.4. Go back to our problem and we'll plug in our 23.4. Check it. The answer checks. We're in good shape. Now we're almost done, so we're going to move on to our apply problem that we all love so much, and we're going to look at real world problems that involve computation with multi-digit decimals. This probably isn't going to be a lot of fun, but let's watch the video and see what they have in store for us.
Mr. Gonzalez is shopping for food at a local farmer's market. He found a vendor that sells fruits and vegetables. He bought 0.75 pounds of pears that cost 98 cents per pound, and 3.5 pounds of plums that cost $1.49 per pound. If Mr. Gonzalez paid for his fruit with a $10 bill, how much change will he receive?
Well, I'm glad he didn't buy oranges and carrots too, because that would have been an awful lot of work. We still have a fair bit of work ahead of us, but I'm pretty confident we can get through this. So, fortunately for us, they went ahead and wrote out the problem so we have it nice and easy to look at. And I'm going to go ahead and pause it while I take my screenshot. And now it's time that we actually start working on this problem. We have got to figure out all the little pieces parts first, which means we got to figure out how much money he spent on pears and how much money he spent on plums. We know that the pears cost 98 cents per pound, 0.98, and we know that he bought 0.75 pounds of the pears. So we have to multiply those two numbers together to find out how much money he spent on the pears. So let's do that first. 5 times 8 is 40, 5 times 9 is 45, plus the 4 from the 40, that's going to give us 49. 7 times 8, that one always bothers me. It's going to be 56. Then we have 7 times 9, that one bothers me too. It's going to be 63, plus the 5 from the 56 is going to give us 68. Add them up, 0, 5, that's going to become 13, and a 7, and then we're going to bounce our decimals. 1, 2, 3, 4, 1, 2, 3, 4. So, rounded to the nearest penny, he will have paid $0.74 for his pears. But we're not done, we're just getting started. Now we get to find out how much money Mr. Gonzalez spent on plums. So the plums cost $1.49 a piece, 1.49, and he bought 3.5 pounds of plums. So with that, we're going to multiply again. 5 times 9, 45, 5 times 4 is 20, plus a 4 from that is 24, 5 times 1 is 5, plus a 2 is going to give us 7. 3 times 9, that's going to give me 27, came over one space for it. 3 times 4 is 12, plus a 2 from the 27 is 14. 3 times 3, 1 is 3, plus a 1 from the 14 is going to give me a 4. Annexing a 0 here might help make adding a little bit easier and add them up. That's going to give me a 5. That's going to give me, whoops, wrote that one wrong, an 11. Just carry the 1, that'll give me a 12 right here. Carry that one, that's going to give me a 5 right there. I'm going to bounce a decimal, 1, 2, 3, 1, 2, 3, which means to the nearest cent, he paid $5.22 for his plums. Now we need to find the total cost of what he spent. So his total cost is going to be the $5.22 for the plums plus the $0.74 for his pears. I line my decimals up. I'm going to add it. 6, 9, 5. Your decimal comes straight down, and that gives us $5.96. We're almost done, but we're not quite. Remember, he paid with the $10 bill. So now we take our $10 bill, and we're going to subtract from it the $5.96 that he spent. I align my decimals up, and we're going to do some borrowing. That's going to become a 0. This one will become a 10. That means that then we end up borrowing from that 10, making it a 9, and making that a 10. But then we borrow from that 10, making it a 9, and making this a 10. So when we subtract all this out, 10 minus 6 is 4, 9 minus 9 is 0, 9 minus 5, that's going to be 4. He gets $4.04 left over for change. Let's check our answer. So we're over on the answer page. We're going to type it in, $4.04. Check our answer, and we checked well. Excellent. That is it for today, guys. Don't forget to show your work. I've been showing you my work. You have to show me your work. If you don't show me your work, I'm going to know you either cheated with a calculator, or you cheated with a phone app, or you cheated with a friend. You cheated somehow, because there's no way, folks, y'all are going to just look at this and know what the answer is. You've got to give me good quality supporting work, or I can't give you credit for doing it. Good luck on your homework tonight.